In this video, we'll be discussing how to describe power cycles, refrigeration cycles, and heat pump cycles. We're going to start with the power cycle, also known as a heat engine. We define it as a cycle that produces net work, or power if we're looking in terms of control volume, via heat transfer from a high to a low temperature reservoir. So what this looks like is here we have our power cycle. We've denoted our system with our dotted line, our boundary. So we have heat coming from our high temperature reservoir into our system. The rest of it that we can't, all the energy we can't capture goes down to the low temperature reservoir, and we're outputting a work net. With our energy balance, this is sum of our heat transfer is equal to our work net, so our heat coming in, heat in positive, this is going to be positive heat transfer coming from our high temperature reservoir, and the heat going to our low temperature reservoir will be negative. We like to think in the cycles of desired and required. So the desired element we want out of a power cycle, what we want is to produce some work. So that's our desired. Our required is we need heat from a high temperature reservoir. Now if we look at the refrigeration heat pump cycle, we're going to do these together and we'll see that they're very similar. They just switch directions in one area. So they're both cycles that produce a desired heat transfer or heat transfer rate from a work input. If we look first at our heat pump, our desired input is going to be heat transfer from the heat transfer associated with our high temperature reservoir. So we have, in this case, we have work net coming in now. Work in is going to be negative, so we have work coming into our system. What we've desired, we've outlined in gray here. We want to get heat going to this thermal reservoir, the high temperature. So what our desired is our heat transfer associated with the high temperature reservoir. Our required is our work net. Now, if we were to look at a refrigeration cycle, the only difference is what our desired is. Now our desired is going to be that heat transfer associated with the low temperature reservoir. We still have our required is still going to be that work net. Another way you can think of how refrigeration and heat pump cycle are associated. Let's look at an air conditioner. This can actually be can show the heat pump cycle and refrigeration, all depending on which way you look at it. If you're inside the room of an air conditioner system, then you are in the low temperature reservoir, your low thermal reservoir. What that means is, the way an air conditioner works is it takes heat out of the room and sucks it in. Basically, it takes the heat out of your room. So in that case, we are the low temperature reservoir, so this would be a case of refrigeration, because that's what we want. We want to get that heat transfer from the low reservoir. Now, if you're standing outside, this is the back of an air conditioner wall unit. If you were outside that air conditioner, you would feel a lot of heat coming out. If you're staying outside, you can think of it, you're next to a heat pump. Now you are in the high temperature reservoir, and you are experiencing all that heat comes towards you. So an air conditioner can actually do refrigeration or heat pump. It all just depends on the direction it's pointed.